Our keynote speaker today is a well-known personality in our community, Hanen, who's chief architect at the CTO office at Red Hat. And Hanen has, we have been engaged for a long time in activities together between OAI and Red Hat. Hanen has a very diverse background. One of the things that he also has a feather in his cap is that he has studied in France, and he speaks very good French. And then he has worked in Canada at Red Hat, and then right now back to Europe, so in Spain. So Hanen has been a great supporter over the years of OAI, and as I said, a sponsor for this workshop. And the interesting, I think that the topic of this keynote is very, very interesting in the sense that all of us are trying to figure out where is 6G heading. I mean, where is 6G going to take us? I think we are in the process of turning a corner. It's a little bit, some of us, or maybe most of us are relatively blind in terms of what are going to be the main takeaways or the important things in 6G. So I'm really looking forward to what your view is on all of this, Hanen. So please. So you can either use this.
I can do it from here. Yes. Yes. Well, thank you, Irfan, and thank you for OAI to have invited us to be here today. It's always a pleasure to work with the OAI and
There you go. Yeah. You like to walk and talk. So.
Okay. That keep me awake. Oh, okay. Yes, so we have been, as Irfan mentioned, I'm part of Red Hat at the Office of the CTO for Telecommunications. And we have been in a long journey now with the OAI team. I'd like to thank as well Professor Knopp, who is here as well. We have been since the beginning on trying to make the radio access network and the core network a little bit more cloud native. And that's back in 2018 or 19, as I remember, where we actually first demonstrate a cloud native system, a mobile system, using the OAI technology. That was really the beginning of our collaboration. I want to take a little bit of a thanks as well to Chris Turton, who is here, who has been now part of the Office of Open Source Program Office, who have been helping us and will help us as well in the relationship with the OAI, and especially here in the US. And as Irfan mentioned, so I took I will say, yes, the early view on what 6G is going to be. As you know, most of you know, we already starting the lead work for specifications and definition of what 6G is going to be. It is happening as well as we speak in Dallas this week. The 3GPP meetings on 6G is going to be part of that. So it's kind of still the early days, but still I wanted to see is we can try to define what principles, especially on the infrastructure, have a look at what is it that 6G demands, or will demand, what it is, what are the shortcomings that we have today in terms of infrastructure for 6G, and see how together with OAI can make this possible, especially on the research side. Okay. With that, as I mentioned, I'm going to go through a little bit of some slides. I will try not to kill you with those, and starting with the demands. I think most of you have heard already the main use cases that 6G will be addressing. Those are incredibly challenging in terms of technology that we're going to be seeing. But going down to what will demands in terms of infrastructure. And sometimes when I refer to infrastructure, I'm referring to the part that we at Red Hat are covering the most. That is the cloud infrastructure, where most of those technologies, network functions will be living in. On terms of that infrastructure, so there are three main things that I wanted to mention here. The first one is about agility and elasticity. So I think today, if we look at the networks, and most of the networks are today by now virtualized, at least using the OpenStack technology on most of the network for 4G. And on 5G, we are looking more into seeing the introduction of Kubernetes for the functions, especially on the core network. So that is providing already some of the elasticity that is going to be required, right? So in terms of being able to spin up services faster, well, with 6G, we will expect that there will be even more requirements in terms of that elasticity and that agility that will be required. Then is the velocity, or I would call it that way. So we will need to be able to sustain the use cases and then dynamically, or dynamicity of the use cases. We need to be able to spin up services much more faster than we're doing today. Typically, we still have long cycles in order to create and spin services. This is something that with 6G we would require much more dynamicity in that regard. And one of the last questions, and let me try to see is this work? Yeah, that works. Is about automation. It's about self-healing. It's about managing the network, or how the network will manage by itself. Okay, and this is something that we will expect by 6G. There is already a lot of work that is being done on autonomous network. That's part of the work on the TM forum. We have been working as well on that. But with 6G, we expect the network to be at least much autonomous as it is today. Now, yeah, I'm going to go back to the podium for this. Yes. So when we're thinking about what 6G is going to need, and just to scratch in the surface here, we're going to see much more requirements when we have the specification more advanced on 6G. But there is what we have today as well, and what is the shortcomings of the infrastructure we have today. There are many things that we have done. So it's, as I mentioned before, we have today networks that are in production with virtualization technology already in place. But what we are seeing is that most of those technologies were not designed thinking about telco, about telecommunications. But we have done a lot of work to make it possible today. So when we're thinking about 6G, we're thinking about how that technology that we have today need to evolve as well. One of the challenge is about determinism, and we have done a lot of effort since the beginning. I remember trying to get the radio working on OpenStack. We succeed to have it working on OpenStack. We succeed to have today in Kubernetes as well. Okay, we will see what the requirements for 6G radio access network will be, and it will be able as well to achieve those requirements in terms of determinism on the real time. The other part is, I will call it the lack of AI native design. One of the things we hear a lot is about the 6G network being an AI native network, and again, we are still discussing what that means. But one thing is clear is what I'm seeing until now is that we have some specifications of what is the network today, and what we're doing is we're trying to put AI on top. When I think of 6G network, I'm thinking as let's start from AI and then put the 6G on top. And this is something that will be through the discussions on 3GPP, of course, but as well trying to see what the implications are on the infrastructure. So basically, we're looking at an infrastructure that is AI native, that will support network functions. And the other one is something that we have seen as well, call it the compute continuum. But because we have been working a lot on the data center, on the core, and as I mentioned, all the virtualization of the core has been done by now. But when it's looking at the radio access network, now we're looking into new components, and we have been testing that as well, especially in terms of acceleration, in terms of transport. So there are requirements that are different compared to the data center, and we have seen that. Now what we need is an infrastructure that is able to deal with all of that, not only on the data center, but as well on the radio access network, and even beyond that, on the customer end as well. And with that, we have some challenges, and we have to see that together on for example, on the O-RAN. One of the challenges with the Open RAN is related to that abstraction, not just the separation of the split, but as well the abstraction between the software and the hardware. And that most of the software that is available out there is still tied to what the hardware is underneath. So we're going to need, and if we're looking at 6G being a more expanded network, then we need to see as well how we cope with that on the infrastructure natively. Not making something after, but looking at it from the beginning. Okay, so with that, we have some, yeah. It should work now, okay. So with that, I have been alluding to this, so there are, and this is something that is probably not new for you guys, it's new, I will work through anyway. It's three things that, basic principles that we're going to need for the infrastructure on 6G. The first one is cloud native, the cloud native infrastructure. I think there is no doubt about this one today. As I was mentioning, there is an evolution that is happening on the network at the same time that the network moves from 4G to 6G, and we're going to see that happening as well from 5G to 6G, is the introduction more and more of the cloud native technologies into the network itself, into the infrastructure. And one of the main reasons is actually, I was alluding to that at the beginning when I say what the challenges are and what the requirements are, is to provide that elasticity and robustness to the network functions. Okay, that's our actually delivering the service for 5G and 6G. The other one is, as I mentioned before, is an AI native infrastructure. And as well, we are still right now in the beginnings of what AI means for telco. And I think this is going to be even further when we're going to have all the discussion on 6G. But it's clear that we're going to be looking at an infrastructure that is completely AI native. And I'm going to dip a little bit on that, what it means, what I mean by that. And the other one that is dear as well to me is with regard to sustainability. We want a network that is much more sustainable in terms of power efficiency and power consumption. So this is something that is going to even increase with 6G, and we're going to see that as well. So diving a little bit into the first one, into cloud native, and I want to see as well how at least the view I have for OAI on that. So when I mentioned about cloud native is, as I mentioned, one of the things and we were seeing is how we're going to introduce the intent into that infrastructure. Today, it's being mostly declarative, and this is something that is being part of the principle of cloud native network. Now what we are looking is how we actually going to introduce the intent, and there is already capabilities that we're going to bring from AI to help us on that. Leverage the cloud native principles. I think this is not new, and most of the software that's being developed today is in line with the cloud native principles. That being said, we are lagging a little bit behind when it comes to telco functions. We know that because of how the telco has been defined, especially on the network side, there are still some elements that need to be stateful, and let's see is what's going to be for 6G. But we will expect that those principles will be even more enforced when we will going to be looking at introducing 6G. And the last part is about the virtualization. And here, when I refer to virtualization, I'm not referring to traditional virtualization. I'm referring to more of the abstraction of the hardware and providing those capabilities to the network functions, as we're talking a network here, but the same apply for IT. We're going to have, and we have today already, an amount of different elements that provide capabilities. We have the acceleration for the layer 1. We have acceleration for the packet processing. We're going to have acceleration for the AI, when it's come to GPUs and DPUs. So we need that layer, that abstraction layer, to be able to provide the capabilities when the application, in this case, the network functions, will require, at the moment they require. So this is something that we expect. This is something that we will see coming. And this is something as well what I will have to see how we can work together with OAI on that. And I have some ideas that I want to bring as we are in the OAI workshop. I have some ideas that I want to see as well. This is something that we should work with. The first one is about the service-based architecture for RAN. So service-based architecture was introduced first on the core with 5G. This is how the core is being, the network function has been served today on the 5G network. There is some discussions that happen. I think I saw a paper as well from OAI on that point into how that look like applying service architecture for the radio asset network. And I think with OAI, this is one of the benefits of what we have been doing, that we have the opportunity to actually try to see how this look like and not just to think about it. So a challenge for the OAI team to see how we can actually prototype around a software service-based architecture for the radio access network. The second one is cloud-friendly transport. This is one of the things as well that was discussed when the 5G was introduced. There are still some protocols that I will qualify not that cloud-friendly. And I remember the first one was the SCTP, when we tried to enable the first radio access network. So there is proposals out there that goes along introducing more friendly protocols for that. This is something that, as well, I believe that is worth having a look at how we can implement those. Especially, there is some research that has been done around quick L4S as well. This is something that's been introduced on the fixed side, by the broadband forum as well, for some services. And the other one is IPv6 for the transport. So that's a challenge as well that we have to see if we can contribute into that challenge. And the last one is, as I mentioned, the acceleration. We have already done a lot of work to have the acceleration for the layer 1 on the radio. We have done as well some work to having the acceleration as well on the core network, especially on the UPF or the pay gateway. We have to see how we extend that, because the number of elements that are going to be part of that infrastructure is going to be increasing. We're going to have DPUs, we're going to have GPUs. So this is something that I think the work has already begun with OAI. We have already OAI. This is available with the aerial kit for NVIDIA GPUs. So we have to see how this expands, as there will be many others GPU makers as well out there in the market, right? Then the AI-native infrastructure, and I think one of the main thing, and as I mentioned before, we are looking at what we have in the network and we are adding AI on top. We are not thinking AI and then adding the network on top. But this is one of the reality, and one of the things that is a challenge. There will be intelligence in all the layers. It's not that we're going to put an intelligence on top. That's what we're thinking. This is how we're thinking today. When we have to look in the future, we will have intelligence in all the layers. We have intelligence on the infrastructure layer, on the service. There will be a layer, I call it digital twins, for the sake of having a visibility on what is happening in the whole network. And there will be a cognitive layer itself as well. The question that most of the time comes up is, how these layers and this intelligence on all these layers will interact between them. So how we make sure that they understand what the original intent is across all the layers, and how we bring the knowledge from all the layers up so that they can learn from each other. This is something that is still early in terms of thinking how the network and how we're going to introduce AI into the network. Of course, when we are looking at autonomous network, we're looking at that cognitive layer, having this layer of automation and autonomy for the network. But there is still that challenge that we need to look at. And with that, I will add some challenges from OAI as well on that regard. The first one is about this AI-driven how we can actually introduce AI to manage the radio access network. There is already a lot of work that's been done along with the ORAN architecture, especially around the X app and the R apps on the RIC. There is a lot of work that the OAI Foundation have done on the introduction of the Flex RICs, and this is a good initial part. Now, when we're looking at those apps are at the moment dedicated to the performance or the improvement of the service. What I'm looking here is how we introduce intelligence to actually manage all the elements, looking into autonomous network. The second one is about the distributed intelligence in the radio access network. There is already, as you probably know, about the OAI Alliance. That is looking into the infrastructure required to execute AI applications in the radio access network. But even though we're looking at ORAN, and we're looking as well at work that's being presented for introducing what we call the distributed apps directly on the node, how we actually make that happen, and what technology do we need there? So we have been working on technology to allow the distribution of AI at scale. And this is something that we would like to see how we can align together into that introduction and distribution of the AI in the entire network. And the last one is the AI native RAN architecture. And this is more as a challenge for the academia at the moment. Is we have to think AI first and the network after. How does look like? Is the ORAN architecture still valid? Is we're thinking that there will be not just a network function, but there will be agents driving those network functions? How this look like in a full AI native architecture? So this is more a kind of something that academia more probably we should look at how we can at least have a look and see what the evolution is of the architecture is we think AI first. Then is energy, sustainability, not something that we have been more present. It is more present now because one of the main scenarios we are seeing for the adding the intelligence on the network is relating to power saving and energy saving, right? This is one of the main use cases that we see when we're looking at the X app and the R apps, how we reduce the power consumption. And this is great. This is something on which we are participating. We did already last year during the Orlando Plug Fest, a demonstration on how we can actually measure, because that the first thing is how measure how much energy the software is consumed in the infrastructure. The next step is how, from what we learn, how we go and act into it. There is as well other points that we need to consider, especially in the life cycle of everything that make that infrastructure, and that include as well the hardware. Okay, how we can make the software in such a way that can extend the life of the hardware, or how can we make possible to replace the hardware dynamically without impact on the service itself. And that is part as well of what I link to sustainability, right? Is the whole cycle, is everything that is on the supply chain when it's come to the radio access network. There is, of course, one thing that we need to start, or at least thinking in a different way. We first create the infrastructure, then we create the functions, and then we thought, we might need to look at consuming less. So what we're going to need for 6G is to think another way around. Is say, let's think already embed into 6G, right? Into operations and the design of the network, that sustainability aspects into it. I'm not going to challenge OAI on this one, but I think my friends I got over there have already some ideas that we're going to implement most probably for the next Plugfest. I wanted to talk a little bit into as well how everything is working together. Especially, as I mentioned, specifications are being done on the standards organizations, but there is as well work that is being done on the open source communities. And here is an incredible opportunity we have with the OpenAirInterface to actually take the lead into what is happening today and what will happen tomorrow for 6G. There is a lot of work that is being done on the OAI Alliance. I think we are collaborating with them. There is work that is being done on the AI RAN Alliance for the introduction of AI. I think that is in progress, Irfan. There is work that's been done on TM Forum when it's come to autonomous networks. There is work that will be done on 3GPP for the specifications of the radio and the core, right? But there is work as well that is done on the open source communities, especially when it's come to the cloud infrastructure on CNCF. And this is something that we need to dive a little bit more when we think about AI first, when we think about what we're going to need in terms of cloud nativeness for the 6G network. Now there is even more work that we're going to be doing together. I hope somebody else is going to be talking about Duranta, so I'm not going to go into that. On the Linux Foundation networking. There is opportunity there with the cloud native, introduction of cloud native technology, introduction of the radio access network technology, the core technology on the super blueprints. So there is opportunity as well to prototype in those and participate on those communities. Now I have to move closer, otherwise not. The good thing is when we're thinking open sources, and this is what open source is bringing, is I think, well, it's not what I think it's already a fact. Open source is there to help move forward the telco industry. We have seen some already good things happening a couple of weeks ago with NVIDIA. That is going to be open sourcing the aerial kit. We saw the introduction early this summer or after the summer with the creation of the project Duranta with the Linux Foundation. And we're seeing as well some competition that is coming in terms of creating even more open source software for the radio access network. And most probably we want to be seeing the same for the core. So open source is here already. Open source is already in the network, and open source will be in the network for 6G. So this is an opportunity we have all together to work collaboratively to make that 6G network and at least try to apply some of the principles that I was mentioning today for that infrastructure on the network. And it's not just about discussing. One of the things we have been doing with OAI and the industry as well is we have been testing already some of those. We are currently working, and I have to do it, so I have to put it on. So we have been working with Sagar and the Red Hat team on this, trying to see how we actually can deploy AI-RAN nodes using the O-RAN framework. So that is one of the things that we're going to need, as we're going to need automation. We're going to need to do the deployment at scale. So this is something that is we are working on. There is the AI-RAN blueprint on the AI-RAN Alliance as well. That's work that was showcased a few weeks ago as well. And the good thing about it is, and now I have to mention that I was in Hong Kong for Movicom, and I have a very interesting panel and discussion over there on ACM. And one of the things that I saw, and there was students and PhD students presenting their work, most of the work that I've been doing for autonomous networks and AI on the networks and 6G is using the OAI software. And this is what we're doing here as well. So most of the work we are doing, for example, on the around the AI RAN is with the OAI software. I think there is a lot of work that still needs to be done, but it's a good starting point. And the last one is I have to do a shout out here to one of my colleagues that is based here in Dallas, but unfortunately they have to be in Europe this week. It's about introducing AI into the network. And this is something that is fully open source. We have been working in looking at different use cases and how to implement those use cases. And why I'm mentioning this is because you all can contribute. You can look at the repo, get what is in there, try it on your own, try to improve that, contribute back, but as well contribute to what you are doing today, okay? This is something that is the beauty of open source after all. There's going to be more that we're going to be adding. Fruit of our collaboration. They're already requesting to have that into this repo. And there is another thing that I didn't put it in the slide, but I want to mention. So we have, and I think Sagar, with you may, I don't know if you were thinking about talking about that later on, but we have the OAI software that's for the radio access network that has been validated and certified on Red Hat technology. So this is something that you can try right now. And if the difficulty is not related to AI, because Sagar made it very simple to make the deployments on top of our platform, is how you create the infrastructure for those network functions. I have one of my esteemed colleagues here, Scott, from the telco team and engineering. We have actually published a complete lab that shows step by step how this infrastructure can be built. Okay, as is open source, is there to let you try on that. And with that, I would like to thank you, everybody. I don't know if there will be questions, but I will be here the rest of the day.
So maybe I can ask you a question. Basically, you know, when you say AI before the network, or I mean, we have the network, and now we're thinking about, you know, how to apply AI to it. Could you elaborate a little bit more on that?
So. Back? Yes. So, well, let me see if I can elaborate on that. So there is work that's been doing in the AI-RAN Alliance, right, around the introduction of AI into the network. And there is several scenarios that goes along that. There is the scenario of AI will be running on the network, so what the network can do for AI, okay? And that is thinking about the over-the-top or thinking about how people will be using AI in the future and how the network will support that interaction. That is basically that. And then is the AI for the network, basically how AI can help on the optimize the network, reduce friction, actually even looking at self-healing and self-scaling of the network. And then there is the other scenario where the radio access network infrastructure could be used as well to serve AI for different purposes in the industry. So there is work that's being done on the three scenarios. Most of the time, what we see is what AI can do for the network, and I think this is where I went through on the challenges for OAI, is how do we introduce AI in such a way that is serving directly the network and optimizing the network functions, and optimizing the performance, optimizing the spectrum, right? This is work that is being done and presented today. I think this is something probably that we haven't deep dive enough with the OAI, and something that we're going to need anyway for 6G.
Thank you for that. Any other questions? This one is going to be difficult because Sagar is deep into this stuff.
I see a good question coming, yeah.
I always wonder about one thing. Do you think the current definition of cloud native, which was designed, let's say, quite a long time ago now, and now the current definition of cloud native, can we use exactly similar in telco, or should we modify it for telco?
Yeah, that will be an interesting question. Thank you, Sagar, for that one. So, as we look at, and you were in the team when we started doing the first positioning of 4G and 5G on OpenStack back in the day, right? We realized that there was already some shortcomings on the infrastructure, on the cloud infrastructure. We saw it even more deeper when we started introducing Kubernetes into it. And the reason is those platforms were not designed think on telco. They were designed think of cloud, right? Now, it is the journey that we are in, and those platforms are now part of the networks. Yes, we made it work. Now the question, and this is still a question, Sagar, is I don't necessarily have an answer on that. Is we're looking at 6G being the network of networks? Okay, what the infrastructure for that network will be, and is the platforms we have will be capable? I believe they will. Okay, but how much do we need to do? And one of the aspects is determinism, right? How do we serve these microseconds of latency on the existing platform? Or do we need to change the service in order that we don't need those microsecond latency? So this is still open for discussion. But what is clear is the platform that we have today will have some optimizations still to be done for 6G. Hope that answered the question.
Any other?
Thank you for the really nice talk. So I have a broad question in the sense that what do you think about quantum or post-quantum security for 6G? Is it too far away, or we are thinking something along that line as well?
That's a good question. So we already have done some work on quantum safe. So to introduce capabilities in the platform, on the cloud native platform for that, to make sure that there is at least some basic aspect of security when it comes to quantum safe. Other thing that and I think is not too far. So is we're looking 6G. Start deployments, I don't know. I might have to ask Doug when are we going to start deploying 6G. But we're looking at 2030. But that time, it's not only DPUs and GPUs that we're going to have in the infrastructure. More probably, we will have as well quantum chipsets as well being part of the infrastructure. And this is something that, particularly, I'm not following that aspect, but we have other people in the company that is looking at those, not only in terms of security, but as well in terms of functionality, what quantum will be able to do for telco. There are some ideas, some scenarios. Let's see, is the technology aligned altogether? So by 2030, we're going to have that technology available as well on the infrastructure. But definitely, we're already working into having that technology available for the infrastructure, and we have to account for.
Thank you, Hanen. Any other thoughts? While you were talking, one thing that came into my mind is, if you look back to the time when the ORAN Alliance was being created, at that time, there was an advantage. We later realized that there were open source stacks that allowed actually implementing, what ORAN was specifying. And that was a great advantage in the sense that we could quickly roll out what ORAN was specifying. In a very short amount of time, we were able to basically showcase what ORAN wanted to do. In the case of the AI-RAN Alliance, that's also the case. I mean, if you look at the open source stacks today, they are pretty mature. And they have all the hooks in there with the ORAN specifications in order to have, to be able to test out some of those AI techniques, et cetera. The communities are also very tightly connected. I mean, we have our colleagues here from Northeastern. Gabriele is here, I think. They are pretty involved there. They're also active in OAI and, other teams as well. So I think we have all the tools in place in terms of all the experimentation that is needed. But I believe that there's a lot of experimentation that is needed in order to really showcase what all this AI. So when you see Alex, tell him that we need to work closer together, and that's one of the objectives that we also have in the LFN, as you mentioned. So Anand, thanks for giving us an overview of all of this. And yes, let's try to get to some of those challenges together.
Absolutely. Thank you.